Welcome! Today, we're diving into the cosmos to uncover some mind-blowing space facts that you probably didn't know. From the incomprehensible vastness of the Booty's void to the mysterious pull of the Great Attractor, we're embarking on a journey to the furthest reaches of space and the universe's deepest mysteries. But before we begin, be sure to subscribe to the channel and like this video. Stick around because you won't believe number 7. Our universe is teeming with galaxies, but what happens when you find a place where there's practically nothing at all? Imagine a sphere of emptiness so vast that it spans 330 million light-years across. This, my friends, is the Booty's void, a cosmic desert that defies our understanding of the universe. Discovered in 1981, the Booty's void has left astronomers baffled and intrigued. Its existence challenges our models of how galaxies form and cluster, raising more questions than answers. We often picture planets as loyal companions, but what if some planets prefer a life of solitude, wandering the cosmos untethered? Enter the rogue planets, celestial nomads drifting through space. These planets, ejected from their star systems during their chaotic formation, roam the galaxy as solitary wanderers. Some scientists believe that rogue planets, warmed by internal heat or possessing thick, insulating atmospheres, could harbor subsurface oceans, potentially teeming with life. The existence of rogue planets expands our perspective on planetary systems and the potential for life beyond our familiar star systems. Imagine a force so powerful, so immense that it can pull entire galaxies towards it like moths to a cosmic flame. This, my friends, is the Great Attractor, a gravitational anomaly lurking in the depths of space, dragging our own Milky Way and countless other galaxies towards its mysterious core. We know it's there because we can see its effects, the gravitational influence that's pulling us and our galactic neighbors towards it at a staggering speed of 1.4 million miles per hour. What lies at the heart of this cosmic giant? Some speculate it could be a supercluster of galaxies, a massive concentration of matter beyond our current comprehension. Chapter 4. Dark Matter, the Universe's Invisible Hand. We often take for granted the things we can see and touch, but what about the invisible forces that shape our universe? Enter dark matter, a mysterious substance that makes up a whopping 27% of the cosmos. We can't see it, we can't touch it, but we know it's there, lurking in the shadows, holding the universe together. How do we know it exists if we can't see it? Imagine a spider web, its delicate threads tracing invisible patterns in the air. Similarly, we detect dark matter through its gravitational influence on visible matter, the way it warps the fabric of space-time, bending light and holding galaxies together. Chapter 5. The Cold Spot, a glitch in the Matrix. Imagine looking up at the night sky and seeing a vast cold spot, a region of space significantly colder than its surroundings. This isn't science fiction, my friends. This is the CMB cold spot, an anomaly in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Some theories suggest that the cold spot could be a result of a vast supervoid, an immense region of space with a lower density of matter than the surrounding areas. Others propose more exotic explanations, including the possibility of cosmic textures, defects in the fabric of space-time left over from the universe's earliest moments. Chapter 6. Hypervelocity stars, stellar exiles. In the vast cosmic dance of stars and galaxies, some stars break free from the gravitational chains of their home galaxies, flung out into the intergalactic void at incredible speeds. These are the hypervelocity stars, stellar exiles traveling at millions of miles per hour, escaping the Milky Way's grasp, destined to roam the universe alone. They are a testament to the immense power of black holes and the chaotic nature of the universe, where even stars can be cast out from their cosmic homes. Chapter 7. The Fermi Paradox. Where is everybody? In the vast cosmic ocean, teeming with billions upon billions of stars and planets, it seems statistically improbable that we are alone. Yet, despite decades of searching for signs of extraterrestrial intelligence, the universe remains eerily silent. The universe, as we're discovering, is filled with potentially habitable worlds, planets orbiting within their star's habitable zone, where conditions might be just right for life as we know it to arise. So where is everybody? Are we alone in this vast universe, the sole custodians of consciousness? Or are there other civilizations out there, perhaps more advanced, observing us from afar? Yapterate. The Oort cloud, a cosmic deep freeze. Imagine a vast spherical shell, a cosmic deep freeze encasing our solar system, a repository of icy remnants from the solar system's formation. This, my friends, is the Oort cloud, a theoretical cloud of icy objects that exists at the outermost reaches of our solar system, a staggering distance of up to 100,000 astronomical units from the Sun. The Oort cloud, while still theoretical, provides valuable insights into the formation and evolution of our solar system. Chapter 9. The Black Hole. Information paradox, a cosmic conundrum. Black holes, those cosmic monsters that devour everything that crosses their event horizon, have long captivated our imaginations, but they also present us with one of the most perplexing mysteries in physics, the black hole information paradox. According to general relativity, anything that falls into a black hole is lost forever, its information swallowed by the singularity of the black hole's core. However, quantum mechanics dictates that information cannot be destroyed, only transformed. Chapter 10. The heat death of the universe, the end of the cosmic story. The universe, as we know it, began with a bang, the Big Bang, a moment of unimaginable energy and expansion. But how does the story end? One possibility, a rather bleak one, is the heat death. A state where the universe reaches maximum entropy, a state of thermal equilibrium where no more work can be extracted from any system. Imagine a cup of hot coffee slowly cooling down as it exchanges heat with its surroundings, eventually reaching room temperature. Similarly, the universe, over unimaginable eons, will continue to expand and cool as stars burn out and galaxies drift farther apart. Until next time, keep exploring. Thanks for watching. If you enjoyed these mind-blowing space facts, don't forget to like, subscribe, and hit the bell icon for more amazing content. Never stop questioning, never stop exploring, and keep looking up at the stars with wonder and curiosity. See you next time.